Good afternoon, everyone. My name is Rafał Kulik. I'm a professor at the Department of Mathematics and Statistics, University of Ottawa. And the goal of this presentation is to give you some introduction to statistics, big data, and finance to stimulate your interest in this field and to encourage you to come to our department, to come to our university and study one of these subjects. Of course, due to the situation, this presentation has to be recorded. If you have any questions, please feel free to send me an email. My email address is here. And at this point, I will turn off my camera so that you can focus on the presentation. I will start with a few quotes and one study linked below here on what is important from the point of view of a job, what kind of career you can have if you know mathematics, if you know statistics, if you know computer science. There is one study from McKinsey, there is one study from JP Morgan that is linked below, and also I looked at a couple of different job reviews, and in all of such type of reviews, in all of such studies, mathematician, statistician, data scientists, financial analysts with mathematics background are among really top jobs from a point of view of the quality of job and also from a point of view of a salary. So you hear a lot of keywords: data science, big data, artificial intelligence, machine learning, data mining, statistics. A lot of these keywords mean the same. When computer scientists talk about machine learning, it may mean the same what mathematicians mean by statistics. Of course, there are some distinct features of each of these fields, but in majority of the cases, people talk about the same things, but use different language. To give you a little bit more idea, so I put the data science in the center of this picture, and you see huge overlap with different subjects. You see a huge overlap with statistics, with data visualization, with machine learning, with data mining, with data processing. This picture is taken from some internet resources. I believe that these intersections are much bigger. In any case, if you know data science, very likely you know a lot about artificial intelligence. If you know statistics, you also know a lot about data science and about artificial intelligence and about machine learning. There is a study done by American Statistical Association. This is the biggest statistical body in the whole world, and they try to identify what does it mean by data science. Okay, and you see that I really emphasize data science because I think this is quite generic keyword that you can apply to machine learning, you can apply to statistics, you can apply to data mining, you can apply to artificial intelligence. So basically, to be a good data scientist, you need to know some computer science, you need to know statistics, you need to know data mining, you need to know machine learning. So in other words, you have to be a mathematician, statistician, and computer scientist. Of course, you cannot be everything to the very high level, but you should know at least some of the tools from each of these fields. So to be a little bit more precise, what is machine learning? Again, this is something that you hear almost every day. Well, machine learning, this is the practice of using algorithms to use data in order to learn from this data and forecast as good as possible. And the tools coming from machine learning are used every day, and you really are subject to them on a daily basis. because they are used in Facebook, they are used in Amazon, they are used in Netflix. Typically, the idea is that based on your past behavior, Amazon will offer some products. Netflix will recommend some movies. Facebook will recommend friends, will recommend some articles, will recommend some products. Well, so we know a little bit what is machine learning. Now let's try to distinguish a little bit between statistician and data scientists. Again, these definitions are not very strict. Very often people mean the same by these definitions. From my perspective, statistician is a mathematician who knows many tools and methods of data analysis, knows how to interpret the data and how to infer, how to extract relevant information. And also, statistician should be able to defend and prove that statistical analysis works. Statistician, of course, knows a lot, some statistical softwares, but may not have big computer skills. So it's rather a user of computing power rather than a creator of computer software. Typical jobs just focusing on Ottawa and surroundings, well, Statistics Canada, different government agencies, or for example, research hospitals in Ottawa. Data scientist typically is higher in terms of computing skills, may have less mathematical background, and is more focused on creating algorithms for purpose of typical of machine learning. And typical jobs you can find in Google, Netflix, Amazon. In local Shopify, they hire quite a lot of people from our department, and credit fraud detection, self-driving cars, and so on and so on. But again, all of these things, machine learning, statistics, data science, there's a huge overlap, but in principle, you should know some mathematics, you should know some statistics, you should know some computer science. Now, you hear a lot, very often, this word big data. So what is big data? Well, this is not about whether you have a lot of data or not. Well, if in the last election, 160 million people voted in total, well, is this data big? Well, it is big because we have a lot of people, but this is a very simple data set. Either people voted for Biden or for Trump. Of course, there were some other candidates, but they were not very relevant. So from a point of view of the analysis, this data set is simple. And even you can try to detect some fraud in this data set. But from the point of view of the methods that you have to apply to analyze this data set, this is quite simple, even if this is big. Now, let's look at gene expressions of two people. So you have just two people, but this is a very complicated data set. DNA code, this is a very complicated piece of information. Prediction of 200 stocks is a very complicated process because you have a lot of interactions between these stocks. Okay, so in this case, even if you say, okay, I have just 200 stocks, even I have just two people, this is for me big data, because for me big data is not about how big is the data, this is about the complexity. To understand this a little bit more, let me show you two examples. Here I have about 50 points on a plane, and the goal is to find clusters, okay? So for example, this could be a cluster of people who have COVID. This is a cluster of people who have mild symptoms, but we are not sure about whether they have COVID or not. This is the cluster of people who have no COVID. You have about 50 points, but this is extremely simple data set because you can clearly identify the clusters. You don't need to be a mathematician. You don't need to apply machine learning. You can identify clusters. Very similar example. I have 20 observations. Try to identify clusters here. Well, maybe this and that. But why not cluster 1, cluster 2, cluster 3. In fact, if you apply different methods here, you will end up with different answers. So even though this is a very small data set, but this is a complex data set for which a lot of methods will break. Another typical example where you have to apply tools related to big data is image recognition. Well, for example, here I can clearly see that all of these pictures on the left-hand side belong to women, on the right-hand side belong to men. But often these pictures are very blurry. For many races, it is hard to recognize from the picture if this is a man or woman. So then you may need to bring some methodology from probability theory. For example, you may have different curves for male and female pictures. And these type of curves most of you seen in high school because these are the so-called bell curves, so-called normal Gaussian curves. And based on these probabilistic models, we can try to identify people based on pictures. Well, we have finance in title. So do we need statistics and data science and artificial intelligence for finance? Yes. I can spend 1 hour on listing different subjects where you use these tools, these methods in finance. If you type in Google statistics and artificial intelligence for finance, you can get millions of hits. So let me just list 4 simple cases. Stock price forecasting. Here, typically one applies simple methods coming from classical statistics and time series analysis. Fraud detection, for example, election fraud. This is where you can use classical statistics. High frequency trading is in an opposite spectrum because here you have to make decisions very, very quickly and you really need to use the computer power. So here, modern machine learning, artificial intelligence techniques will apply. Portfolio management, this is the situation where we will use both classical statistics and modern artificial intelligence approaches. So you can see that all of these tools, statistics, data science, machine learning, artificial intelligence, they are used together in many, many different contexts. So let me go to 2 simple examples from finance. One is about forecasting. Most of you have seen this type of picture for stock prices, okay? The question is, what will be the stock price tomorrow? Should we invest or should we sell? Well, we can do simple regression line that you learned in high school most likely and try to use this regression line to predict. However, this prediction, this forecasting is not very good, as you can see from this picture. This line doesn't really fit well my data. So you need to learn a little bit more tools, more sophisticated mathematical tools to do good forecasting. And this is something what we teach our students in the 2nd year in statistics or in the 3rd year in time series analysis course. Let me do another example that this example can be done for portfolio management. This example can be done for Amazon and product selection. This example can be done for Netflix and movie recommendation. So I have 2 countries, US and Canada. I have 2 types of industries, oil and travel industry. And from the past, I know whether these companies made high profit, low profit, or they had a loss. Okay, so I have a company that I have a company in hand, and when I want to decide, do I want to invest or not? Of course, this is extremely simple situation because I have 7 companies. I can do everything by hand, but in the real life, you have dozens of companies, dozens of industries. You have political events that influence stock prices. So the situation is 100 times more complicated. But let's go through a simple example. So first of all, what is important? Country or type of industry. I highlighted companies from Canada. You can clearly see that all Canadian companies make a loss, okay? So certainly when I have a company from Canada, I'm not going to invest, okay? So now let's see the second factor, the type of industry. You can see that the travel is not extremely profitable. Well, two companies made a loss and one company made some profit. So certainly oil industry in this example is much more profitable than travel industry, okay? So what we say is that the type of industry is not really a determining factor. The country is the determining factor. So then what's next? We look at US companies, and then here basically the data is all over the place. So oil company, one company made a high profit, one company made a loss, one company made a low profit. So based on this simple example, people who made financial decisions very likely will do as follows. If you have a Canadian company, don't invest. If you have US company that comes from oil industry, invest. If you have US company that comes from travel industry, then well, we are not sure, okay? So this is extremely simple example, but this is the type of examples that in the real life require really an automatic decision based on some tools coming from machine learning. So do we really do such things at the university? Do we only teach you different theories, or we do some practical things? Well, let me give you one example of a work of myself and my student, Yusuf Sissoko, a student from Senegal, who we worked together on a problem from one company from Ottawa. You can find a little bit more about this whole work in the link below. The point is as follows. A company has clients and wants, based on the client's behavior, they want to decide whether they should give a loan or not. This is what all the banks do, but the process is quite long for the banks because they really need to do a proper credit check. In this case, the company gives small loans and the clients want to have a quick access. So there is very little data involved. So here really the problem is small data, which is sometimes more complicated than big data. In any case, we did some work, and this work was well funded, and the student got some very good experience and a good salary. Well, all of these examples that I try to present you here, where do they lead you to? Well, you can, having all of this type of knowledge, you can work at the university or at different research institutes. You can get job at Google. We have people who studied here and got jobs at Google. I don't know personally any students who ended up in Amazon or Netflix, but we have a couple of people who work for Shopify in Ottawa. Any institutions that require some fraud detection, like Canadian Revenue Agency. Well, Canadian Border Security Agency does a lot of machine learning applications, and I was involved in some of these applications. RCMP, yes, police uses machine learning to detect different issues. Of course, Bank of Canada does a lot of forecasting. Statistics Canada does a lot of forecasting. So all of these institutions require, they need people who have mathematics, who have statistics, who have computer science as a background. So can you learn all of these things in our department? Yes, you can. We have a couple of options, and I will go very briefly through these options. There are links below that you can navigate and learn more about these programs. And again, please send me an email. We have a honors bachelor or major in statistics. So the focus is on statistics, less on computing. Then we have program which is run by the Faculty of Engineering. This is honors bachelor in computer science with data science options. So this is really a lot of focus on computing, less on statistical tools, less on data mining. And there is a new program. This is integrated program called Honors Bachelor in Mathematics and Honors Bachelor in Computer Science, Data Science. So this is a 5-year program. It combines 2 degrees. So yes, you have 2 degrees when you finish this program, and you learn statistics. So basically you learn everything from honors in statistics. You learn computer science, you learn machine learning, you learn data mining. So we have also financial mathematics program that is very popular. This is less on computing, more on statistics, more on finance. But if you need more details, please feel free to contact me. That's all for my presentation. Again, if you require any further information, please feel free to contact me. My name is Rafał Kulik, and I'm happy to answer your questions. Thank you very much, and have a good